12.4, equilateral and isosceles triangles. So we're going to start with an isosceles triangle, and remember that an isosceles triangle has two congruent sides. So then we look at our image. Our two congruent sides are called the legs. They are equal in length. And then we have our base down at the bottom if we kind of sit him. We have our vertex angle up at the top. And then the most important here is going to be our base angles. So our base angles are the two angles at the bottom, which kind of sit opposite or across from our legs. Now, why these are so important is because of our base angles theorem. And our base angles theorem says that the two base angles in an isosceles triangle are congruent, meaning they're the same measure. So in our picture, if I were to tell you that my first base angle over here is 30 degrees, then I could conclude that my other base angle over here is also 30 degrees. Now, the converse of the base angles theorem, so when you hear the word converse, I want you to kind of think of the word opposite or opposite direction. So the base angles theorem says that in an isosceles triangle, I know I have an isosceles triangle, the two base angles are congruent. Well, the converse says if two angles in a triangle are congruent, then the triangle is isosceles. So if you're looking at a triangle and I'm telling you, so for example, an example of this could be a triangle, and I tell you that this angle is 45 degrees, and I tell you that this angle is 45 degrees. Well, from there, we could conclude what the third angle is, but it is different, so only two angles are congruent. Then I can say, oh, this is an isosceles triangle, and these two sides are going to be congruent. Equilateral triangle. So remember, an equilateral triangle does not have two congruent sides, has three congruent sides. Which means, another way of putting that is all the sides are congruent. Now, if all the sides are congruent, then we can also conclude that all the angles are congruent. So in an isosceles triangle, we have two sides congruent, so we have two base angles that are congruent. In an equilateral triangle, we have three sides congruent, so we can conclude that we also have three angles congruent. Now, if the three angles are congruent, and we know that in a triangle, all angles add up to 180 degrees, then we can take 180, divide it by 3, which gets us 60 degrees. So I know that in an equilateral triangle, all of the angles are going to be 60 degrees. And that is true every single time, but only if you're looking at an equilateral triangle. Example 1, using the base angles theorem. So if we're using the base angles theorem, we're back to an isosceles triangle. It says complete each statement. If HG is congruent to HK, then angle blank is congruent to angle blank. Well, if these are my two sides that are congruent, then you always have to look kind of like down and opposite. So that's going to give me angle G and angle HKG. So angle G and angle HKG. Now, notice for angle G, I can just name it with a G. The reason is because it's the only angle sitting out here. Okay, but notice at angle K, I use 3 letters. The reason is because if you just say K, I don't know if you're talking about this K or this K. So you have to be very specific and say HKG, so I know that you're talking about the one over here on the left. Part B. If angle KHJ, this one, is congruent to angle KJH, this one, then what side is congruent to what side? Well, this guy is opposite this side, so it would be this one. This guy is opposite this side, so it would be this one. So I can say HK is congruent to KJ.